Hi, my name is Nadia Post, and this is my Lab 3 magnetic field of a bar magnet. The objective of this lab was to measure the distance dependence of the magnetic field, compare predictions found from the Biot-Savart law and computational model in order to find moment of a bar magnet. The fundamental physics principles was that the bar magnet models a magnetic dipole, the Biot-Savart law, which is seen on the right, and the distance dependence formula on the right. The results that we found was that the distance dependence is equal to negative 3.0429 and that the magnetic dipole moment is 2.21 amperes meters squared. During the experiment, the system was the bar magnet and the surroundings were everything else. Our initial conditions were the bar magnet and magnetometer on phone, and the process was that we used the magnetometer, find the magnetometer by sliding phone along ruler and detecting strongest magnetic field, and then we took the required measurements. We had two different sets of data, the analysis on axis and the analysis off axis. With the on-axis analysis, we measured the on-axis distance from the bar magnet to the magnetometer using a ruler with several different magnetic field values. The x component of the magnetic field is 0, and Earth's magnetic field does not interfere. Values were then linearized by taking the natural log of each side. For the off-axis analysis, we found the on-axis distance from the bar magnet to phone so that the net magnetic field was 100 microteslas, and the y component was found by subtracting the Earth's contribution to the y component of the magnetic field from the total y component of the magnetic field. Some observations we found was that when the magnetometer is far away from the magnet, it measures a near zero magnetic field in the x direction, and as you move that magnetometer closer, the measured x component of the magnetic field increases. We also found that the phone position matters, so the Earth's magnetic field does not interfere with readings from the bar magnet. Some of the calculations we found from the graph data was that the slope was negative 3.0429, which is the distance dependence. The intercept is the natural log of k, which is negative 14.632. Finding k, we find 4.42 times 10 to the negative 7, and the distance dependence equation is below as follows. Afterward, we solve for the dipole by setting the Biot-Savart law equal to the distance dependence equation, and doing so, we find the dipole, which is 2.21 amperes meters squared. During the code, we created a magnet with an inputted mu value. We also created our function for the dipole and Biot-Savart law. We created 6 errors for our observation locations, 2 for on-axis and 4 for the perpendicular. We found the magnetic field at 45-degree angle through the code as well. Below is the output of our code, and as you can see on the left, we have all of our values for the different observation points, as well as the magnetic field at the 45-degree angle at distance d. For the code and model, we found that the theoretical off-axis field should have been equal to 2.7 times 10 to the negative 5 teslas, but our experimental off-axis field was 6.36 times 10 to the negative 5 teslas. This is about an 80% difference. Model discrepancies and sources of error. So the model discrepancies are very little because a bar magnet's magnetic field is typically very close to a magnetic dipole, so it is very accurate. Some sources of error would be if the location of the magnetometer on phone may not have been found very precisely, which would skew distance results from bar magnet to the magnetometer. Discussion. In the experiment, you oriented your setup so that as to compensate for magnetic north. What if you hadn't done that and had instead laid out your meter stick at some intermediate angle with respect to Earth's magnetic field? How would your results change? Our results would have changed and made them incorrect by including Earth's magnetic field. Earth's magnetic field would skew the results. What if? Imagine you had 2 identical magnets. What if you redid the experiment, but instead of using a single magnet, you used 2 identical magnets stuck together end to end? How would you expect your measurements to differ? our magnetic field would be greater. The measurements would increase by about double, and even though it would have the same direction, we would have a greater magnitude. And some conclusions. The Biot-Savart law and distance dependence can be applied to bar magnets to yield accurate results. Bar magnets can be used to accurately model magnetic dipoles, and distance is an important factor to consider in determining the strength of a magnetic field. Thank you.